And I probably ought to open the chat in case any of you chat. Come on. There we go. All right. Yesterday, last night, and I know Todd was there. I don't know if either Marissa or Cody were there. We started looking at working with files and pretty much right now text files. We saw how we could write to a file. And let's see, let's go back one more, or even back one. The first thing we did was we just wrote one line. And when you want to work with a file, you have to assign it a handle. They call it a file handle. In reality, it's a variable naming the file. And I just used FH for file handle. And we said to open it. And the name of the file in this case. And in this one, the A is append. You can open a file for reading, writing, or appending. And when you open for writing, if the file exists, it wipes it out. But if you open it for append, it adds data to the end of the file. So this one was appending, and it asked for a name and an age, and we just wrote that with a file handle dot write and put the name and the age, and we can use all of the formatting we could use for the print function with the write function to write out the way we want it. Unlike the print function, it doesn't put a new line, so we have to put a new line character if we want it to go to the next line after it writes. We may or may not want to do that. That's something you will decide depending on the program. We then said, okay, we'll create a loop, and we created a loop that would go through the loop and ask for the name. If you put the name, the last one we did, if the name was blank, so it had a length of 0, if you just hit enter, then it would break out of the loop. Otherwise, it was going to ask for the age and write the name and the age. And we ended up with a file that looks like this after we ran it a couple of times. So by appending, I could enter, say, 2 of the names first time, exit the program, run it again, enter one name, so I can add to it like you would to a database or something that way by appending. So that's writing to a file. Any questions there?
I have none.
Okay, to read from a file, you open it as well. And again, this method will look at another method of opening, but for this one, again, it's the file handle equals, and then the open command and the file name. I called it test3.txt this time. And we're opening for read. So we're going to say, I want to read that file. I don't want to write to it. So the open command, you still have to open. When you're reading, it's not as important, but when you're writing, we always want to, the last thing when we're finished with it is close it. But in between, we'll process it. There's a couple of ways of reading the file. And one of which is, excuse me, is essentially reading the whole file at once, or if it's a very large file, instead of reading it, the whole thing at once, we can actually read a buffer or buffer in part of the file. Depending on the type of data you're using, you might do that. I normally only use that when I'm dealing with a dealing with a binary file. Right now, if we just open for read or write the way we've done, we're opening text files. If I did an RB, I would say this is a binary file. A binary file typically is something like a image, a JPEG or PNG image, could be a video, it could be an audio file. Those you would open as binaries. But most of the time we're working with text files, so we don't need to do that. But if we can do this with text files as well, but if we were opening or reading a binary file, you typically use the FH read or file handle, the name of the file variable, again, FH is what I'm using, read, and that reads the entire file. If it's a really big file, inside the read parentheses, you can put in a buffer size and tell it, instead of reading the whole file, to read, say, a megabyte of the file. And we'll work on that. And then we can then read the next megabyte and the next megabyte. You look at video files, they could be a gig or bigger. And so you may not have enough memory to do the whole thing. So that's why you might, if you're manipulating those kind of files, just read part of it. If you're dealing with any of those, there are libraries for manipulating graphics files. Okay, so if I'd run this one, since I'm using the read, it should read the entire file. And so it read, and I read it and printed it directly. I could have read it and stored it in a variable and then dealt with it. But just to see, I just printed it, and it read the entire file and printed the whole thing because I told it to read the whole file. Most of the time, if we're dealing with text, we're not going to read the whole file. We're going to read a line of the file at a time. So let me here. Let me close a couple of these. And to read a line at a time, there's 2 or 3 ways of doing it. The way that I probably start most of the time is in a for loop, and I say for in a variable. I used line because it's going to read a line at a time. So in this case, for a line in the file, and then I just printed the line. I don't want this one yet. So then I just printed the line. And so if I run this one, it's going to go through the for loop, and it's going to print each line. So each time it runs through the for loop, it's going to read the next line from the file, and then it's going to print that line. So if I run the debug on this, okay, it is sitting here. It's opened the file. It's at the for loop. It's not read the first thing. So it tells me from variable standpoint that it has opened the file. Tell it to go next. It goes into the for loop. And so it read the first line, which was Sharon 34 and the Newline character. And when I tell it to go next, it's going to print that to the console. So here it printed the Sharon 34. It's back up to the top of the loop. And when I tell it to go in again, now it reads the next line, which was the Margaret 34. Actually, let's leave that. And I'm going to just keep going through. There's Bob, Joe, Samantha, and I think Samantha There might have been one more. So now it's going to print Samantha, goes up to the top of the for loop. Well, that was the end of the file, so now it exited the program. So the for loop, where you give it a file handle, says go through and process that one line at a time. A carriage return, the Newline function, is how it knows the end of a line. The Newline function is how it knows the end of the line. Now, when I ran it, notice there's the blank line between each of those, between the Sharon and Margaret and those. That's because it includes that Newline character. So we could get rid of that by doing a couple of things. I could do comma end equal, just quote to say not to put a new line in, and you'd still have the new line that was part of the data. And that got rid of the extra line. Or let me comment this one out so you can see. Or the other way, we could do the line dot strip, and the strip gets rid of white space on each of them, and the Newline character at the end is considered white space. Remember, the strip gets rid of any white space at the beginning or the end, but doesn't get rid of white space in the middle. Both of those will get rid of that extra Newline. Doesn't matter in this particular case which way we do it. If we weren't printing out the data, if we were doing other manipulation of the data we're reading, then stripping that Newline character might be important. So here again, the for loop here lets us go through essentially one row at a time or one line at a time and process it. Now, as we go on, what we're going to end up doing is reading in files that have delimiters and such, and we might need to strip things or do other manipulation. So here I've got my test3.txt file, and here it is. So any questions so far? Now I've got another file, text or read to, and actually let's go ahead and, I've got a read text, and it's just got some lines, and so if I were to go back and take what we've done here, read to, right? Or was it read? No, I want the read right now. Read.text. Here again, I could go in and print each line. And strip off the end line. Just doing this just so you see the data. So different size lines. Again, carriage return line feed indicates the end of the line. But what if I've got data that may be delimited and I want to process it? So here I've got a file, this read to, and I've got some commas at different places. I just threw them in at various locations just so you can see how it deals with them. but files can be delimited, or data can be delimited variously. And so I do have the read to that's got some delimiters in there. Let's actually stick with read for a minute. In addition to being able to strip out things, and I'm just for ease to keep this simple, I'm going to get rid of that. I can split, and we've not looked at split before. Split, or the split method, says if I read a string, I want to split it on a delimiter. Now, if you don't put anything in the parentheses, the delimiter that it splits the line on is the blank space, is white space. So if I split this, if I run this with just the split here, what it does is it creates, in this case for each line that we read, it's going to create a list, and it's going to take each item in that list, and it's going to separate that string by the space bar. So it's got this as an element of the list, is as an element, a, line. And so the blank spaces in read become the delimiters. And so each time there's a blank space, that says, okay, the next thing is going to be another element of the list. So that is how we can take a string and in its simplest form, split it into multiple items or values, elements in a list. And once it's in a list, we can process it the way we would process any list. Now, if I go to the read to, I can hit the right key. If I run this as is now, when it processes it, it says this comma inside the quotes. So this comma is actually the first element in the list. Is comma is the next element because there were the commas here in the file. So, but it's still splitting it on a blank space. Well, what I probably want to do in this case is actually split it not on a blank space, but on the comma maybe. So if I want to split on the comma, in quotes, I put a comma. And so let's see what happens now. And now it splits it wherever there was a comma. So this, then the space is, the blank space got counted. The blank space here got counted. So it did split it on the comma, but left in the space. A lot of times you get data in that's comma separated values, and if it's clean enough, you can actually separate the different items this way. Now, if I don't want the space in each item in the list, somebody want to give me an idea of how I would get rid of that? Get rid of the space in the quotes.
Use your strip method.
I could use my strip. What else?
And your split, you could put a space comma or a comma space.
Comma space, because that's the way it is. Yeah, that would be the easiest. And it'll come up in just a minute, I hope. Sometimes it, because the recording takes a break. There it did. And so now it got rid of the spaces. I still got that Newline character. Notice at the end of each line, the Newline characters are there. So I might want to manipulate and get rid of that one. So let's go one step further and get rid of the Newline. And if you were doing this, you would you would put all this together in some way. So I'm going to do here first, I'm going to do the line dot split outside the print statement, and do the comma space, but I need to store that somewhere. So I'm just going to say X equal. So it's going to create a list X. And if I run this now and print X, I get to wait again. There we go. That gave us the same thing as I had before, but I know that on the last element, I need to get rid of that Newline character. So I could replace just in that one, X in position -1. Now the -1 does what?
Goes to the last element.
Goes to the last element, is equal to, if I just said X of -1, it wouldn't change anything. But what I want to do with X of -1 is I want to strip off the white space. So if I, just on that element's the only thing I need to strip off that from. So just in the last element, strip off the Newline character and replace that with the same value without the Newline character. And there we've gotten rid of the Newline character. The idea was take it a step at a time and think about what it is you need to get rid of. Just take it a step at a time, think about what we need to get rid of as we go through. So once we get a line of text in, we can figure out the order and things we need to get rid of things. There's one other way I could have done this. Actually, I said one other. There's probably a dozen other ways. But what I could have done is I could have said X equal line split, or line dot strip. Or actually, I'm going to say line equal. I didn't have to do a different one. Line equal line dot strip. That would get rid of that Newline character at the end, and then I could split it. And I end up with the same thing. So either way, in this case, would work. I stripped off the Newline character at the end before I split the text, or I could split the last one. Both would work. Again, two ways of doing it.
Since you're using Linus for your for loop, would you want to use Linus to assign it the value again like that?
Well, in this case, I'm replacing the current contents with the new contents. So I am taking away that just on this one line. I'm taking away that Newline character and just replacing it. I could even here have said line, but since I'm going here from just text, a string, to a list, I probably wouldn't want to do that. But here, I'm just taking away the white space or the Newline character at the end, so it doesn't hurt. But if you wanted to use another variable, that would work as well. So that's another way I can, or a way I can read data and start manipulating it.
Okay.
There is a read line that will read just a line of text. And I thought I had that in my scratch, but I don't. If you do the read line, it reads in a whole line of text where you don't have to have it in a for loop. I've not found that all that useful, and the reason I've not found it all that useful is I usually have to process every line of the file, and so the read line just reads or processes a single line. And so I could say in a loop of some sort, if I knew there was 100 lines, range 100 or something like that, and then do the read line in the loop to process every line. The one place where you might use that, and you need some other commands, and we're not going to get into that one, I just want to make you aware of it. We open this for reading. If you were to open the file for read plus, you're actually saying instead of sequentially reading, we're going to be able to randomly read from it. So opening a file for reading says start at the beginning and go through. If you open a file for read plus, you can actually then move back to the beginning of the file or move around in the file with an index and do things instead of sequentially doing randomly. The logic to do that is a little more complex and not something we really need to worry about for this class. The times that I have used the read plus is typically when I'm manipulating some sort of binary data. If you are familiar with EXIF data from digital images, the EXIF data, when you take a picture, say with your cell phone, it will have the name of the camera or the phone in the case of the phone, the focal length, the aperture, a lot of that information. There's other things you can add, copyright information. You can add latitude and longitude if you've got a GPS. By the way, if you haven't turned it off and you take an image with your cell phone, it is going to store the GPS data in that file. So that could be good. You go back through and say, where did I take this? But if you're posting those pictures online, somebody can download them, look at that GPS data and know where you're at. So there is a privacy aspect to that one. Most of the phones, the camera will let you turn it off, and a lot of the apps to post things on different social media sites will let you strip off that data. But be aware, your cell phones have GPS data. Now, some of us, a lot of things I do, I want GPS data. On mine, when I take pictures, go back through, this is kind of off topic, but go back through pictures you took 10 years ago and try to figure out where they were taken. That's when the GPS data can be handy. I've got film that I've been scanning from the 70s through the 90s, and as I scan some of it, I'll look at it and I go, where were we? Where was that taken? And I don't have any idea. So GPS data can be good. Okay. All right. So that's basics of reading from a text file. Any questions there?
My question is that where do you where does the text where's the text stored? Where's the text files stored?
Okay. I created this text file ahead of time, and I placed it in the same directory or folder as all of my programs. Okay, that's a good question. When I created in the earlier ones, yesterday's, when I created a text file, if I just give it the name of the file, it will put it in the same folder or directory as your program. So what you might want to do at times, actually, let me go back to one that I'm writing. That'll be easier. And we'll even go one more step. I hard-coded the file name actually in the open. You could actually have a variable file name or whatever you want to call it. And whatever the file name is, and I could put here file name. Notice I don't need the quotes, and this would still do essentially the same. But if I wanted the file written in a different directory or folder, or in the case of reading, if the file was in a different directory or folder, I could put the path in there. So maybe I'm going to do G:\/ documents. And as long as I had a G:\/ documents folder, then it would create the file in that directory. So if I don't put any path, it will create or read from the directory I'm running the program from. If I put a path in, it will go out to that path. Now, right now, if I try to run this particular program the way it's written right now on a Linux box, I will get an error because Linux doesn't use drive letters or anything. I would have to change the path to be proper for Linux. Right now, I'm running on a Windows box, so I'm good. And so I tell it that one. I think I've got a documents folder off the root on G, and evidently I don't. So.
Interpreting the slash as an escape character?
Huh?
Is it interpreting your slash as an escape character?
Actually, I think it was there too. And that may have been it. You may be right. The first one it was, the second it didn't seem to be. Let's see. Actually, I got an extra quote there. No, because it still got two. I'm not sure what it was doing. I have to look that up and see why it was doing the double.
If you use double quotes instead of single quotes, will that help?
Well, I tried the double quotes before.
You had your double quotes within the single quotes.
Actually, what I should be doing is this. Well, it's still putting it as a double.
Well, you need it in front of the test too.
Well, the test has still got the test 2 part is right, showing right, but let's try that. You may, well, okay, so it did need it on both. I'm not sure why it was showing the double before and not here, so yeah, I need to escape those out. Need to escape those out, and so Dan's an old feller. And so since I did have on my computer on my G drive a folder called Documents, so there's my G drive, and there's Documents, and there's Test 2. So yes, you can supply the path, and a lot of times you may need to supply a path. You could even have the user enter the path. Now, if you're having the user enter the path in an input, you might need to validate that they put a correct path and all. And there are ways of doing that. All right. Does that answer your question, Cody?
Yes. Thank you.
All right. Okay. Any other questions about what we've done today? What I'm going to do next, while you're thinking, is we're going to look at processing comma separated value files. And after we do the CSV files, we'll look at JSON files. I'm not going to try to do XML files because the libraries for processing XML are kind of a kludge, I'll guess, and it's XML are much harder to process because they're not as structured as JSON. JSON, XML, and comma separated CSV files are very common generic ways of passing data from one application to another. A lot of things create those. There is actually also, there's a library for reading Excel files. So there's actually a library that will let you read Excel files as well. I played with it, and that's about all I can say about that. I could take, for example, I can go into D2L. I could export your username and things as a CSV file, and then I could bring them in here and manipulate them and do things with them. I could export my entire grade book for a class and then come in here and process the grades. Again, saving them as a CSV file. D2L doesn't give me the ability to save as JSON. One of the things we'll probably do next week is we'll actually go and pull some data from a website and download the CSV data from a website and process. Anybody come up with any questions? Well, this is where, for me, it starts getting fun when we start putting all this together. All right. Well, if there's no questions, I'll go ahead and we'll go ahead and end and see you guys next time you show up.
Okay, thank you.
All right.